Question number one. This question is about salts. Green copper carbonate and sulfuric acid can be used to produce blue copper sulfate crystals. 1.1 is a combination of AO2 and AO3 question, and it is from the required practical activity number 8. Excess copper carbonate is added to sulfuric acid. Give 3 observations you would make. So this question is actually from neutralization topic and soluble salt. So we can see from here a sample diagram is given. Copper carbonate is a green color. It reacts with sulfuric acid. It makes copper sulfate, carbon dioxide gas, and water is formed. In the observation, we will see that the green color in the beginning it reduces, and we can see that the blue color is forming there. It shows that copper carbonate makes a chemical reaction with sulfuric acid and makes copper sulfate, which is blue color. So the green color disappears and the blue color substance is formed. Another thing is that the fizzing of the gas is going on in the reaction. It is due to the formation of carbon dioxide. So as a result of the neutralization reaction, we know that we will get a soluble salt, which is copper sulfate. We will get carbon dioxide and water. Let's see the model answer. Green copper carbonate will start disappearing with time. Fizzing or bubbling of the gas, which is carbon dioxide, will start in the beginning of the reaction. At the end of the reaction, blue copper sulfate will form and fizzing of the gas will stop. 1.2 is an AO1 question from the same practical activity number 8. How can the excess copper carbonate is removed? So this topic is from the soluble salts. The insoluble copper carbonate which is left behind can be removed by the process of filtration, or you can write filter out the excess copper carbonate. So the model answer is by filtration method, or the student can write filter out excess copper carbonate from the solution. 1.3 is again an AO1 question, and it is from the required practical activity number 8. The pH of the solution changes during the reaction. So when the reaction will start, the pH will change. What is the pH of the solution at the end of the reaction? So this question is from the neutralization reaction. As the result of the neutralization reaction, the soluble salt is formed and the water will form. The water has a pH of 7. Therefore, the pH of the solution at the end of the reaction is 7. If we go back to our chemical reaction, we know that the copper carbonate and sulfuric acid, this is acting as a base, this is an acid, it makes a soluble salt, copper sulfate, carbon dioxide gas is formed, and water will form at the end. So it is a neutralization reaction. So in the neutralization reaction, the pH at the end of the reaction is 7. 1.4, copper carbonate and sulfuric acid react to produce copper sulfate. What type of the reaction is this? So I put the chemical equation here. When copper carbonate it reacts with sulfuric acid, it forms copper sulfate, carbon dioxide, and water is formed at the end. So whenever an acid reacts with a substance, as a result a soluble salt and water is formed, that chemical reaction is called neutralization reaction. So the model answer is neutralization reaction. 1.5 is ammonium nitrate is a salt. Figure number 1 shows the maximum mass of ammonium nitrate that can dissolve in 100 cm cube of water at different temperatures. So temperatures are given along x-axis. The mass of ammonium nitrate that can dissolve in grams per 100 cm cube of water is along y-axis. A graph is given here. So in figure number 1, we need to see that what is the maximum amount of ammonium nitrate which can dissolve in the water with at different temperatures. A student adds ammonium nitrate to water at 80 degree until no more dissolves. The student cools 100 cm cube of the solution of ammonium nitrate from 80 degree to 20 degree to produce the crystals of ammonium nitrate. Determine the mass of ammonium nitrate that crystallizes on cooling 100 cm cube of this solution from 80 degree to 20 degree. So the temperature drops from 80 degree to 20 degree. We need to use figure number 1. From figure number 1, we can see that at 80 degree, if you go straight up and go straight left on side there, we will get 83 grams is the quantity or the mass of ammonium nitrate which can dissolve in 100 cm cube of water. And we know that it is given the temperature drops from 80 to 20. From 20, we will go straight up and go on the left side. The quantity of the ammonium nitrate which can dissolve in 100 cm cube of water, that is 32. The difference between them is 83 minus 32, and the answer is 51 gram. So the quantity of the crystals formed at the result of cooling from 80 degree to 20 degree is 51 grams. Let's see the model answer. Mass of ammonium nitrate dissolved in water at 80 degree. We need to use the figure, that is 83 grams, which I showed you in the figure number 1. The mass of ammonium nitrate dissolved in water at 20 degree. You can check it from the graph, that is 32 grams. The mass of the ammonium nitrate changes in crystal form, that is how much the mass is formed in the form of crystals. 83 grams minus 32 grams, that is 51 grams. So due to the decrease in temperature, the dissolved ammonium nitrate will start appearing in the form of crystals.